Good day sir, good day everyone. This is the report of Group 3, the Ocean Current System. So, ano nga ba itong tinatawag natin na ocean current? Ocean current is a continuous directed movement of seawater generated by a number of forces acting upon the water, including wind, the Coriolis effect, breaking waves, coupling, and temperature and salinity differences. So, ang ocean current, ito yung tuloy-tuloy na direktang paggalaw ng tubig sa ating karagatan na nabuo dahil sa mga pinagsama-samang force ng hangin, yung Coriolis effect, breaking waves, coupling, yung temperatura, and salinity differences or yung pagkakaiba-iba ng alat ng ating karagatan na nag-a-act sa surface ng karagatan. So, how does a current work in the ocean? Major surface ocean currents in the open ocean, however, are set in motion by the wind, which drags on the surface of the water as it blows. The water starts flowing in the same direction as the wind, but currents do not simply track the wind. The wind pulls surface water with them, creating current. So, yung hangin, siya yung humahatak sa surface or dun sa ibabaw ng ating karagatan para makakreate or makabuo ng current. Ito yung tinatawag natin na agos sa Tagalog. Next is the geostrophic force. So, what is geostrophic force? The force acting on the wind at right angles or 90 degrees to its direction of motion from left to right in the northern hemisphere and from right to left in the southern hemisphere. This force is not effective in the latitude within 5 degrees from the equator. This is also known as the Coriolis force. So, ang geostrophic force, ito yung force na nag-act sa hangin at right angles or 90 degrees to its direction of motion. And hindi siya effective sa lugar kung saan 5 degrees yung latitude along the equator or malapit sa equator. At ito yung tinatawag natin na Coriolis force. So, ano nga ba yung Coriolis force? Coriolis force is an effect whereby a mass moving in a rotating system experiences a force acting perpendicular to the direction of motion and to the axis of rotation. On the Earth, the effect tends to deflect moving objects to the right in the northern hemisphere and to the left in the southern hemisphere, and is important in the formation of cyclonic weather system. So, yun nga, gaya ng sinabi natin kanina, ito yung force na nag-a-act perpendicular o sa direction of motion and to the axis of rotation. So, kasi yung Earth umiikot, bali nakabuo siya ng force na nag-a-act perpendicular dun sa axis ng rotation ng ating mundo. And it is important in the formation of the cyclonic weather system. So, importante siya sa formation ng cyclonic weather system. What causes geostrophic force? This occurs because the Earth is rotating. So, ayun nga, nangyayari to dahil yung mundo ay umiikot. The rotation of the Earth results in a force being felt by the water moving from the high to low, known as Coriolis force. The Coriolis force acts at right angles to the flow, and when it balances the pressure gradient force, the resulting flow is known as geostrophic. So, ayun, meron tayong diagram. Ito yung low pressure natin. Ito yung low pressure area, ito yung high pressure. So, ito yung Coriolis force, yung force na nag-act perpendicular pababa, yung flow niya. Tapos, ito yung pressure gradient force, yung red na yan, yung pataas. So, pag na-balance yung pressure gradient force, ito yung nagiging result, yung geostrophic current. The effect of the geostrophic force on the surface current. So, ano nga ba yung effect ng geostrophic force sa surface current? All ocean currents are affected in somewhat similar way. as the winds by the Coriolis force, which is due to Earth's rotation near the surface. The current is thus deflected about 45 degrees from the wind direction, and this angle increases with depth. The resultant deflection of the surface water effect directly concern the navigator, but the behavior of the whole body of water largely governs the actual current circulation. So, yung effect ng geostrophic force sa surface current or sa ating karagatan, ito yung nagiging dahilan ng pagtaas ng tubig ng tubig sa ating karagatan. So, yun nga, inaabot ito ng about 100 fathoms or 600 feet yung maximum depth niya. So, ayun, kaya may tinatawag tayo na high tide.
The generation of drift currents by prevailing winds. Drift currents. Ano nga ba yung drift currents? Means currents caused directly by the wind. Sabi dito ay nangangahulugan ang mga alon ay dulot ng hangin. When the wind blows over the open sea, it provides a drag force on the top layer of the water, circulating in the direction towards the wind. Immediately moving water is affected by the rotation of the earth, whose motion is deflected by a ton to the right in the northern hemisphere, to the left in the southern hemisphere. This is why current generated, a wind drift current, does not flow parallel to the wind, but an angle between 20 degree at 45 degree to the right of the wind direction in the northern hemisphere, to the left is the southern hemisphere. Ibig sabihin, kapag umihip ang hangin sa bukas na dagat ay nagbibigay ito ng persan ng paghatak o di kaya pag drag ng force sa tuktok na layer ng tubig na nagpapalipat-lipat sa direksyon patungo sa hangin. At ang paggalaw ng tubig ay apektado sa pag-ikot ng mundo. Gradient currents. What is gradient currents? Gradient currents caused indirectly by the wind or by density differences in adjacent areas. Ibig sabihin, ang gradient currents ay ang mga alon na sanhi na hindi direktas ng hangin o ng pagkakaiba ng density sa mga katabing lugar. When it happens that two adjacent areas of the water have quite a big difference in temperature, the resulting density differences causes a pressure gradient in the water. The result is the horizontal flow of the water called gradient. As the water moves, it is deflected to the right in the northern hemisphere, in this case to as much as 90 degrees from its initial direction, to the left southern hemisphere. As an example of this kind of current is the eastward current in the Bay of Bengal in February. Another in the warm Gulf Stream current, which is the most remarkable current of the ocean that flows along the east coast of and North America in north to northeastward direction of the Florida towards Cape Hatteras. Sabi dito, kapag nangyari na ang dalawang katabing lugar ng tubig ay may isang malaking pagkakaiba sa temperatura, ang nagreresulta ng pagkakaiba sa density ay nagdudulot ng pressure gradient sa tubig. At kapag nangyari ito, ang resulta ay nagiging pahalang o horizontal yung flow ng tubig na at ito ay tinatawag na gradient.
Causes and kind of ocean current. The two primary causes of current is wind stress and pressure gradient within the water and has something to do with the difference in density. So what is wind stress? Wind stress is the shear stress exerted by the wind on the surface of large body of water, such as ocean, seas, estuary, and lakes. It is the force component parallel to the surface per unit area supplied by the wind on the water surface. Yung wind stress is yung um, siya yung para tumutulak sa current natin para lumakas lalo. Mostly makikita siya sa mga oceans, seas, estuary, and lakes. And wind stress is affected by wind speed, the shape and the wind waves, and the atmospheric stratification is one of the components of air-sea interaction within other being and atmospheric pressure on the water surface, as well as the exchange of heat and mass in the water and the atmosphere. So, ito yung itsura ng wind stress. From colder region to tropical region. Ayan yung makikita nyo. So, ayan yung picture niya. Example niya pala. So, what is pressure gradient? Pressure gradient is the rate of change of atmospheric barometric pressure with regards to horizontal distance at a given point in time. Air pressure created by the motion, size, and number of gas molecules present in the air. Differences in air pressure and the pressure gradient force are caused by the unequal heating of Earth's surface when incoming to solar radiation and concentrate na equator. So, ito yung itsura no pressure gradient natin. From low pressure area, mapupunta siya dito masicirculate siya dito sa high pressure areas. Ganun din si high pressure area. Pupunta rin siya. Kung masicirculate lang yung sabihin natin, from warmer, tapos biglang lalamig, tapos lalamig, biglang iinit. Na, ang nagtutulak sa kanila is yung wind natin. Kaya pansin nyo, meron tayong low pressure tsaka high pressure area sa dagat.
Kung may primary, syempre meron din tayo secondary. We have 5 secondary causes of ocean currents. And what are those? First, depth of water. Means the depth of water between the surface and the seafloor as measured at mean lower low water. Ito ay nagkukos ng ocean currents kasi ang pagkakaiba-iba ng water density or tinatawag na dermo at kaalatan ng dagat or kasinan na tinatawag na hailing. Ito yung nagkukos ng ocean currents na proseso na tinatawag na thermohaline circulation. Next, underwater topography. Topography is the study of the land surface. In particular, it lays the underlying foundation of a landscape. Paano nga ba siya nagkukos ng ocean currents? Ang mga currents na nasa ibabaw at sa taas, ibabaw at sa ilalim, na dumadaloy mapa-locally man daw or globally, ang mga hangin at water density ang nagdadala sa ocean currents. At syempre, nakaka-influensya ito sa location, direction, and speed ng barko. The shape of basin in which the current is running. Paano nga daw siya nagkakos ng ocean currents? Kasi ang shape ng ocean basin at yung mga malalapit na mga landmass, ito yung nakaka-impluwensya sa mga ocean currents. At syempre, ang ocean current kasi, meron niyang force at physical characteristic na nakaka-apekto sa size, shape, speed, and direction. Next, location and direction. Paano nga ba siya nagkakos ng ocean currents? Kasi ang pag-ikot ng Earth ay nagre-result ng Coriolis effect na nakaka-impluwensya sa ocean currents. Mamaya, magbibigay ako ng example sa next slide ko na ng Coriolis effect. Deflection by the rotation of the Earth. Yun nga, paano nga ba siya nagkukos ng ocean currents? Ang planet kasi ay nagpo-produce ng force. At ito yung Coriolis effect. Ito yung example ng Coriolis effect. Anyway, yung Coriolis effect ay yung yung direction nito, yung naka-bends or sa Tagalog, nakabaluktot. Ito ang example ng Coriolis effect. Kung nakita nyo sa screen, itong arrow na to, ang Coriolis effect daw, kapag bumangga ito sa dito bumangga ito, nagbabago siya ng direction. Ayan, kung makikita man, dire-diretso, tapos yung nakabangga siya, nagbaluktot na yung direction niya. At ayun yung Coriolis effect.
The effect of unusually high or low barometric pressure. High and low barometric pressure. Low pressure system has lower pressure at its center than the areas around it. Winds blow towards the low pressure and the air rises in the atmosphere where they meet. As the air rises, the water vapor within it condenses, forming clouds and often precipitation. Wind of low pressure system swirl counterclockwise north of the equator and clockwise south of the equator. High pressure system has higher pressure in its center than the areas around it. Winds blow away from high pressure, swirling in the opposite direction from a low pressure system. The winds of a high pressure system rotate clockwise north of the equator and counterclockwise south of the equator. Low pressure weather system usually lead to cloudiness, wind, and precipitation. Sa low pressure, dito nakapakaloob yung stormy day or rainy day. Low pressure is associated with rising air. Isang magandang halimbawa sa low pressure weather, yung tinatawag na LPA or low pressure area. Once na sinabing ang isang lugar ay nasa loob ng LPA, malaki ang tsansa na makaranas sila ng mahina hanggang malakas na pag-ulan. High pressure system usually lead to air, calm weather. Sa high pressure naman, yung sunny day, high pressure is associated with sinking air. Ang hangin ng high pressure weather ay palabas dahilan para mataboy ang ulap. Sa kabilang banda, ang hangin ng low pressure weather ay paloob, kung saan mas naiipon ang mga ulap dahilan para maging cloudy ang weather.
The global surface water circulation chart. The seasonal changes in the above in areas under the influence of the Asian monsoon. The current in the North Indian Ocean, including the Arabian Sea, Bay of Bengal, reverses in direction seasonally following the northeast and southwest monsoon. From November to January, when the northeast monsoon is blowing strongly, the current circulation is mainly counterclockwise in the region bounded by India on the north, Africa to the west, the equatorial countercurrent to the south, and Sumatra and the Malay Peninsula to the east. From February to April, the current weekends in some areas become variable as this is the transition period to the strong southwest monsoon. When the current reverses, that is, it circulates clockwise in the direction from May to September. Kung mapapansin nyo dito sa picture na to, ito yung Indian Ocean. Ngayon, kapag November to January, northeast monsoon yung dumadaloy dito, which is cold season. Ito yun. Ito yung northern part ng Indian Ocean. Ngayon, itong 0 degrees, ito yung equatorial countercurrent. Yun naman yun. Tapos, kapag naman sa buwan ng February to April, ang hangin naman na magbo-blow is yung southwest monsoon, which is summer season na. Ayan na yan. Ngayon, kung napapansin nyo, bakit parang sa baba ng Indian Ocean is parang yung direction iba kasi yun yung purpose ni equatorial countercurrent. Kumbaga kung ano yung direction ng hangin sa taas, siya naman yung kina-counter niya sa baba. So, ayan na. Parang sa taas, counterclockwise. Pagdating dito sa baba, nagiging clockwise. Yan yun. Next is, ito yung itsura ng Indian Ocean sa right. Tapos, Pacific Ocean sa gitna. Tsaka Atlantic Ocean. Ito yung mga monsoon. Yan. Yan yun. Pag napansin nyo yung counterclockwise na direction, ibig sabihin yan, northeast monsoon yan. Pag yung mga clockwise na direction naman, yun yung southwest monsoon naman. In the open waters, in this area current set easterly. The speed of current of south Sokrota reaches up to 7 knots, which is the strongest ocean current in the world from July to September. In the South Indian Ocean, the main current circulation is counterclockwise. The westerly south equatorial current forms the northern boundary to the south. It is bounded easterly southern ocean current at about latitude 35 degrees south. At several hundred fathoms, the current may flow in the opposite direction to the surface current. This shift direction with depth combined with a decrease in velocity with depth called Ekman spiral. So, balikan muna natin yung dito sa sa baba ng southern part ng Indian Ocean. Sabi kasi dito, 'di ba? Yung direction ay yung current circulation is pa-counterclockwise, which is true nga. Ayan o. Pa-counterclockwise siya. Ngayon, para bumaba siya, dito siya dadaan. Dito sa may agulhas current. Yan na yung tinatawag na agulhas current. Magiging agulhas current na siya, papunta dito. Tapos parang naging na siya, kumbaga dire-diretso na siya. Yun na yung tinatawag nila na sayang. Ito naman yung picture ng mga ocean. So, ito, yung nasa left side is yung sea. Ito si Indian Ocean. Ito namang nasa gitna, si Pacific Ocean. Ito namang nasa right side ay si Atlantic Ocean. Yan, sila yon. In the open air water in these areas, current sets easterly. The speed of the current south from Sokrota reaches up to 7 knots, which is the strongest ocean current in the world from July to September. In the South Indian Ocean, the main circulation is counterclockwise. The westerly south equatorial current from the northern boundary into the south, it is bounded easterly southern ocean current at about latitude 35 degrees south. At several hundred fathoms, the current may flow in the opposite direction to the surface current. This shift of current direction with depth combined with a decrease in velocity called Ekman spiral. So kung babalikan natin yung picture kanina, ito yung south equatorial circle. Kung mapapansin nyo yung direction ng hangin niya dito is pa counterclockwise, 'di ba? Tulad nga nung sabay dun sa ano kanina, mainly counterclockwise yung direction ng current sa South Indian Ocean. Ngayon, dito siya dadaan. Ayan. Kung mapapansin nyo, umikot siya papunta dito. Ayan. Ito naman yung tinatawag, ito yung nag-shift na siya ng direction. Ayan yun. Yung nag-shift siya ng direction. Ito naman yung tinatawag ng Ekman spiral. Yan naman yun. Ang Ekman spiral is yung pag-shift ng current direction with depth combined with a decrease of velocity. Ayan yun. So, ito yung picture niya. Ayan, ito ni Ekman spiral. Ayan. Ito yung itsura ng Ekman spiral na nanggaling sa Swedish oceanographer na si Vag Walfrid Ekman. Ang theory niya kasi about dito is yung direction daw ng surface current will be approximately 45 degrees to the right of the wind direction kapag nasa northern hemisphere and additional 45 degrees to the left of the wind direction kapag nasa southern hemisphere naman. So, kung mapapansin nyo yung mga araw-araw na yan, bawat araw na yan, nagre-represent ng strength and direction ng current. So, kung mapapansin nyo, para siyang naka 90 degrees sa wind direction. Yun yung theory niya. Naka 90 degrees siya. So, ganun din yun sa ano. So, pag nasa southern hemisphere naman siya, magna 90 degrees din siya. Yung direction niya ng... Tapos, ito naman sa figure B, ito naman yung Ekman layer. Kung saan, yung force ng wind dito is balance. Kasi, by Coriolis force. Ayan. Kung nakikita nyo naman yung Coriolis force. So, alam naman natin kung ano yung Coriolis force, di ba? So, ito naman yung current table. Itong current table na to, ito lang yung mga definition dun sa bawat yung mga parang yung remarks lang kung yung drift ng dagat. Ayan, no? Sa North Equatorial, 10 to 40 drifts miles, average drift miles per day. Tapos neutral temperature. Yan lang naman yung mga parang another information about sa current sa Atlantic Ocean, Indian Ocean, saka sa Pacific Ocean. Yun.
Victory!